Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we will be implementing algorithms and data structures using Scala functional programming approach. This is the Dijkstra shortest path algorithm, part 4. In part 1, we had understood how Dijkstra shortest algorithm works and we have seen an example how it will traverse and find the shortest path. In part 1, we had implemented weighted graph. In part 2, we had implemented, part 3, we have implemented helper methods for the Dijktras, and this part 4, we will be implementing the rest of it, and finally, the shortest path algorithm. Link to part 1, part 2, and part 3 will be found in the description of this video. So let's complete this. So here till now, we don't need X, so we can use underscore as a pattern. Now let's add one more helper method, add neighbors to route. So eventually there are going to be multiple neighbors because it will be dealing with level, so it will be dealing with all the neighbors at a time. It's similar to BFS. Okay, so add neighbors to route. This method again, it will be having a type parameter, so we will have all neighbors, which will be sequence of weighted edge of type V. Now it's going to be path of sequence of path of type V. Then it is going to return an accumulated path, accumulated route. Basically it is going to be again sequence of path of type V, and again it will have an implicit. Everything is happening on graph, so implicit for a graph of type V. Spelling mistake. Okay, so what is going to return? It's going to return again sequence of path of type V. Let's implement this again. All neighbors pattern match, so it's going to be a match where it is going to be case of nil. When it is nil, it is going to return my route. If it is not nil, then we'll split into head and rest, and we have new path that is basically update route, and we will be using x comma path comma acc route. So we are calling update route every time. So we had created update route here, so this will work on one neighbor at a time, and this is for all neighbors. So now this is going to pass to add neighbors to route, and here I'm going to do pass this value and new path. Okay, perfect. Till now we are good. So now the finale, it's going to be the shortest path. Shortest path algorithm. All right, let's implement. So it's going to be shortest path itself and type V. So we will have a starting node which will be of type V, and we need an implicit of graph. Everything happens on that graph of type V. Implicit. So what we are expecting it to return a sequence of path of V. Now let's implement. Okay, so how it is going to be? First we need to know the neighbor of the start. So it's going to be graph dot neighbors and start. It will give me a sequence of weighted edge. Then we need to know the start path. Start path. So start path is going to be path of sequence of start. So because initially there is nothing, weight is going to be 0 and it is just the beginning of the node. Now let's add a shortest path helper. Shortest path helper will be using the neighbors, which is basically sequence of weighted edge, and we have a path that will be sequence of path of type V, and it will be returning a sequence of path of type V. So let's implement neighbors match. It's going to be first, as usual case of nil, so it is going to return the path. If not, then there is some value, and for that value new neighbors is equal to n dot flat map. Say we have, you can use any variable here, graph dot neighbors, and it's going to be t. So it is t dot destination, then only we will get the value. Okay, so we got this value, and we call this shortest path helper with new neighbors and with add neighbors to the route, where we'll pass n, which will be the if there is any value left out, or if our shortest path or the neighbors are not empty, and we will pass the path and the path itself again. Okay, now the real magic comes. We need to call the shortest path itself with the values. What will be the value? So first is going to be start neighbor comma start sequence of start path. Alright, this is how we plan to implement. There is an implicit missing. Now we need to call this helper. This is going to be the helper. Yes, so it's perfectly done. Now let's test it. Hope so that it works fine for us. So val shortest path is equal to shortest path, and we start with the node A. So now it is going to give us the entire list of path from A. Let's print SP and see whether we have achieved success or not. So it's building now. The project is building now. It's compiling, and here it goes. 3 2 1. Okay, so first path is A to 0, then A to C is 3, then A to B is 4. Similarly, ABG is 5, and AC is 5, ABE F6 4, again 6. Perfect. So we are getting a perfect output. Let's calculate shortest path for a couple of them. So how we are going to calculate? So we are going to use println, and it is going to be sp dot filter underscore dot route dot last is equal to h. This is going to give me shortest path till h, and we will again do this for say f. Let's run it, and let's see whether we get our shortest path to h or not. Okay, so shortest path to H is A, B, G, H, 6. Let's see. A, B, G, H, 6, 4 plus 1 plus 1, 6. Okay, now for F, A, B, E, F, A, B, E, F, 4 plus 1 plus 1, 6. Perfect. So this summarizes our shortest path algorithm. Now, if you enjoyed this video, please like and subscribe, and do not forget to press on bell icon for any future updates. And code to this particular implementation will be shared in the description as a link to my GitHub repository. Thank you.